Hello, so in this video we're going to continue looking at simplifying algebraic expressions, and we're going to start looking at this idea of expanding. Now, the word expand literally just means to make something bigger. So in this context, what we're looking at is trying to make an expression bigger by removing the brackets. For example, let's suppose I had something like this. So x, and then in brackets, x plus 3. Now, what this literally means from a mathematical point of view is that we should deal with the x plus 3 first, and then we'll deal with the x term afterwards. And what's going on in between these two things? Well, there's a multiplication. Remember from the first video, if we don't have to write multiply, we don't bother, right? But the way which I want you to think of this is that essentially we've got an x term. So this is like one person, a Mr. X if you like. And he is visiting a house. That's what the bracket means, okay? We're visiting a house, and inside that house there's two people. And guess what? These two people are called Mr. X and Mrs. 3. That's what that literally means. Now think about it. When you go to visit somebody's house, you should always visit everybody there, because otherwise it's just rude, right? Now what I mean by this is that when we're trying to expand this, we need to make sure that everything outside the bracket visits everything inside the bracket. So in other words, this x has to visit this x and also this 3 as well. Now, what do I mean by visit? Well, really, all I mean is just multiply them together. That's how we visit things in algebra. So x times x, well, that makes x squared, doesn't it? You remember from my first video, if we're multiplying x by itself twice, we should write it as x to the power of 2. Okay. But then we also have this x visiting this 3, positive 3, remember, because the plus tells us it's positive. So we have x times positive 3. Well, doesn't that make positive 3x? Like, that's how we'd write that. So this would be this thing expanded out. We'd have x squared plus 3x. Okay. What about if I had something like this? For example, 5y multiplied by 2y minus 6. Well, let's think about this. Again, everything outside the bracket has to visit everything inside the bracket, and the 5y is just one term. You remember that? So we have 5y has to visit this 2y. Well, let's think about that. 5y times 2y. Well, let's deal with the numbers first. 5 times 2, that makes 10. But then we also have y times y. That makes y squared, right? So we have 10y squared. But then we also have to have this 5y visiting this negative 6. So we have 5y times negative 6. 5 times 6 makes 30. So therefore we have negative 30y. Okay. Now we may also have terms like this, or expressions like this. Let's try, for example, x times by 3x plus 7y minus 6xy. So now there's 3 terms. But you just remember everything outside the brackets has to visit everything inside the brackets. So just 3 people living in the house, if you like. So the x visits the 3x, which makes 3x squared. We also have the x visiting the positive 7y, which makes positive 7xy. Remember, we write the variables in alphabetical order. And then we also have the x visiting the negative 6xy. Well, what's that going to be? Well, it's going to be negative 6. And then when the x times the x becomes x squared, and then we just have a y hanging around at the end. Does that make sense? Like just the x multiplied by negative 6xy. The only thing that we can combine together there is the x times the x, which makes the x squared. Everything else is just being multiplied. What about if we get given something like this then? Let's try negative 3a multiplied by 4a minus 6. Well, let's think about this. You've got to remember here, it's not just the 3a that visits everything inside the brackets, it's the entire term, including the sign. So negative 3a multiplied by 4a. Well, negative 3 multiplied by 4 makes negative 12. But then we also have to have the a times the a. That makes a squared. Okay. And then we have negative 3a multiplied by negative 6. Well, negative times a negative makes a positive. And then we have 3 times 6, which makes 18. And then we just need to multiply that by a. Does that make sense? What if we get given something like this then? So let's try x plus 3 multiplied by x plus 4. Okay. Now here this is a little bit more tricky, but it's the same kind of principle if you think about my house example. because what it literally means is that we have now 2 people visiting the house. We still have the house, which contains Mr. X and Mrs. 4. Okay, but now we've got 2 people visiting them. We have a Mr. X and we have a Mrs. 4. Sorry, Mrs. 3. Yeah, so the X plus 3. So all it means is that everything that visits them has to visit everything. So the X has to visit everything in this bracket, and the Mrs. 3 has to visit everything in this bracket, right? So let me show you. Everything in the first bracket has to visit everything in the second bracket. We have X times X, which makes X squared. We have an X times a 4, which makes a positive 4X. But then the Mrs. 3 also has to visit everything in the second bracket. So we have a 3 multiplied by an X, and we have a 3 multiplied by a 4. Then the only thing left to do is to collect together like terms. So would you be happy looking through here? I've got unique terms, 3 unique terms. I've got an X squared term, I've got X terms, and I've also just got number terms. So let's think. How many terms are there just with an X squared in? There's only 1, which means I just leave it as it is. So I just leave it as X squared. Then I go through and I say, right, how many terms are there with an X in? Well, look, there's an X term there. There's also an X terms there. So I have 4X and then I have 3X. I'm adding them together. So I should end up with 7X. Then finally, I'm just left with a positive 12 on the end.